Welcome to the project presentation for data management and database design, Spring 2025 online. Team 1, are you ready to go?
Yes.
Okay, it's all yours.
So good morning, everyone. Welcome to our presentation on the Animal Adoption Database Design Project. I'm Ling Wei. I'm doing the kickoff of project overview.
And I'm Chizhang. I do the final ERD introduction part.
I'm Chen Wei. I'll present the SCOTGL implementation for you.
My name is Feng Yao. I'm doing the data analysis report 1.
I'm Jun Hao, and I do the data analysis report 2.
And I will start with a brief introduction to our team and what we have been working on. We're a team of 5 members, each have different part of the project, from ER modeling and schema design to business rules and implementation planning. So our project focus on designing a robust and a scalable database design for animal shelters. The animal adoption database is intended to streamline day-to-day shelter operations and support critical decisions by keeping all important data in one place. From tracking animals and medical report to managing adoptions and donations, our database covers every major aspect of shelter activities. Next, please. So today, some of the animal shelters often have some problems with fragmented or manual data systems. They are lack of adoption, inventory tracking, or donor management. So our database is designed to solve those pain points. We do those things like centralize shelter data, improve transparency, and enable better planning. The goal is not only to manage data efficiently, but also to support real-world decisions, such as matching pets with adopters or forecasting supply needs. Next slide, please. So throughout this presentation, we will walk you through the key part of our project, ERD, entity descriptions and the business rules, query logic and the reporting features, design modification and the final structure, and our data visualizations. So I think it's Chizhang's turn to introduce us about our ERD.
So our database is designed to help animal shelters to manage animals, adoptions, donations, and events. It integrates information about adopters, vet, and the shelter staff to ensure the smooth operation and to keep tracking of each animal's medical and adoption history. So we can have a high-level overview of the entities. First, we have the shelters. The shelter is store the detail of each shelter location, like name and address, capacity. And the shelter have some relevant entity like the event. The event is to manage the event hosted by a shelter. And it contains including the date, the capacity, and the status and other properties. And we also have inventory. The inventory is to keep track of the shelter supplies like food, like medicine, and it has some properties like the date and the categories, quantities, and unit. And we also have the donations. The donation is to record the donor's information and amount they donate. And we also will introduce the shelter staff later. And we also have the person. The person is the capture common personal information to help us avoid duplicate contact information across multiple roles. Like we have many person, like adopters, the shelter staff, the vet, and the vet, they also additional attribute like their specialization. Like the vet, they have their specialization, and the shelter staff, they have their salary, and the adopters, they have their personal address and personal like their adopter name. And we also have some another domain like relate to animals. The animals is the heart of the system with attribute like name, like gender and color and other properties. And we also have the breed of the animals, and they can connect by the animal breed table. And we also have the health report for the animals, store the medical record and link each report to animal and the vet to conduct the exam. And we also have a pet state tracking table and to maintain an animal's adoption status timeline. They also have the pending, approved, reject, or complete status in this table. And we can have see some key relationships and introduce them. We have the first is to the shelters and the animals. Each shelter hosts many animals, but an animal is belong to exactly one shelter. So we design a one-to-many relationship from shelters to animals, and with a shelter ID as a foreign key in the animals. And we also have the animal to the adoption application. One animal can have multiple applications if multiple people are interested, but each application is for one special animals, specific animals. And we have the person. The person is related to vet, to shelter staff, and to the adopters. And a single person is recorded can link to exactly one spatial table if that person is a vet or a staff. And there's animal and relate to breed. It's connected by the animal breed, because an animal may have multiple breed, and each breed can have described multiple animals. So we designed a junction entities to represent this many-to-many relationship. And we aim to keep our design to at least in the third normal form. So by separating out our roles, like the vet, the adopters, and the shelter staff in their own in their own table, and this is our the ERD form is the basis of the circle DDL statement to ensure all tables and the relationships are properly defined. And next we'll show how these entities translate into the create table statement and demonstrate some sample queries and views we have designed.
I'll be discussing the SQL DDL implementation of our animal adoption database. As you already see in the ERD presentation from Zhang, I will focus especially on the key implementation aspect rather than the database structure. During the presentation, we will have some code snippet in the slides. I will pause for several seconds for you to look to the snippet and before I go to the next point. Next page, please. Let me highlight several important implementation features in our DDL. First, we implemented comprehensive check constraint like for enforced data integration. For instance, application status value are restricted to specified value as shown here, like below. The status will only be withdrawn, rejected, approved, or pending. And second, we create computed column for derived data. The animal table automatically calculates an animal age based on its date birth. Oh, the back to the previous slide, please. Okay, and then third, we implement the custom validation function like function validate animal DOB to ensure data quality. Okay, next page, please. And then, oh, sorry, that gives me a moment. Okay, so I think we can go to the next page. Next page, yeah. And then we have created two important views to specify common report need. The V adoption summary view joins adoption application, person, and animal tables to generate comprehensive adoption report as below. The V animal details views combine animal information with shelter and breed detail for quick access to complete animal profiles. To conclude, our SQL DDL implementation provides a robust foundation for animal shelters management. The structure enforces data integrity through constraints, enables complex reporting through well-designed views, and ensure business rules are constantly applied. This is the basic overview of our SQL DDL implementation, and now I'll hand the mic to my teammates to the report one.
Next page, please. Hey, I'm going to talk about the data analysis and visualizations. And my report is more focused on the business values and optimizing animal shelter management. Next page, please. So my point here is to track the number of animals currently housed versus each shelter maximum capacities and help identify overcrowded shelters like Springfield and Riverdale near full, and enable better intake planning and resource allocations, and support decision like transferring animal or expediting adoptions. As you can see on this chart visualizes the current occupancy at each shelter compared to their maximum capacities. You'll notice like Springfield and Riverdale are both very close to being full, which tell us when to trigger transfer or encourage more adoptions. This tool helps optimize operations and prevent overcrowdings. Next page, please. And for this slide, I'm more focused on role distribution visualizations. Majority of record are adopters, followed by shelter staff and doctors, and reflect the primary user of the shelter systems. It helps assess staff to adopter ratio and future resources needed, and support the user role-based customization and permission logic in database design. As you can see on the chart, we broke down the user role in our systems. Most users are adopters, and followed by shelter and doctors. This tells us where to focus on system usabilities and also help shelter plan resources like staff assignments and user access permissions. Next, please. And this slide, I'm more focused on the geographic trend adopted by the cities. The Springfield shows the highlight number of adopter in the data set, and geographic trends help guide marketing and outreach strategies. And high activities areas can support more events, shelters, or fundings. And lastly, the visual like this can be filtered by time for trend analysis. And the bar chart highlight the adoption activities by cities. Springfield stand out with the most adopter, which suggests we could prioritize outreach or event planning there. These kind of visualization also help uncover underserved region that may benefit from additional support. Next page, please. Yeah, so to summarize this up, this slide is more focused on insight and business impact. So to visualization allow us to turn raw shelter data into insight that directly support decision making, whether it's reallocating animals to avoid overcrowding or planning event in high adoptions cities like Springfield. Our system gives shelter teams the visibility they need to operate smarter and more compassionately. Okay, and I'll give it to my another teammate for the report too. Thanks.
And in this part of data analysis and visualization section, we continue building on the insights from report 1, which explored how data can guide decision making in animals shelter management. Well, report 1 focused on high-level patterns across user roles and adoption behavior. Report 2, which I will present, dives deeper into how shelters are actually using their resources, both in items of space capacity and donation funding. By visualizing the number of animals hosted compared to available space and mapping donation distribution among shelters, we uncover meaningful imbalance that can help inform better planning, resource allocation, and fundraising strategies. This report highlights where shelters may be under pressure or underfunded, and how data can guide smarter support across the system. And go to the next page, please. In this first chart, we present a comparison between each shelter's total capacity and each current animal count. For example, we can see that Happy Tail Sanctuary is operating near full capacity with 95 animals out of 120 slots. Similarly, Loving-Hurst Animal Rescue has 83 out of 110. On the other hand, shelters like Second Chance Shelter and Paul's Claus Center have noticeably lower occupancy rates, meaning they still have space for more animals. This kind of comparison helps us evaluate how efficiently each shelter is utilizing its resources. It also informs future decisions, such as where to transfer animals if certain shelters become overloaded or which shelters might need expansion. And go to the next page, please. And this chart visualizes the donation distribution among different shelters. We can clearly observe that Loving-Hurst Animal Rescue received the largest share, accounting for almost 40% of total donations. Positive Haven comes next with about 20%. In contrast, shelters like Happy Tail Sanctuary, Animal Angels, and Furry Friends Refuge received very little funding, in some cases even below 1%. The uneven distribution here could be related to factors like public visibility, the frequency of fundraising campaigns, or shelter reputation. These insights suggest which shelters may need better promotional support or more targeted fundraising efforts in the future. And go to the next page, please. On this side, we have combined the previous two visuals to provide a side-by-side comparison. This makes it easier to evaluate whether the shelters receiving more donations are also the ones housing more animals, and whether the funding is aligned with operational needs. For instance, Loving-Hurst Animal Rescue has the highest donation percentage and also one of the largest animal counts. That's consistent. However, a shelter like Paul's Claus Center houses a significant number of animals but receive very little financial support. This misalignment highlights the need for data-driven resource allocation, ensuring that donations are fairly distributed based on actual operational demands. And move for the next page, please. That brings us to the end of our presentation on the Animal Shelter Management Database project. And thank you for your time and attention. We welcome any questions or feedback you may have. That's all. Thank you.
Yes, I have a question. Can you hear me?
Okay.
Sure. Could you please explain what types of data validation like you implement in the database design?
Data validation.
No, the database design.
Yeah, I think we have implemented two main type of validation. First, we created custom functions to prevent invalidate birth date of animals. And second, we have used domain constraints to enforce validate value range for a different type field. This validation help to maintain data quantity and prevent errors when entering the information into this system.
Does anyone have other questions?
Yes, I noticed you implemented several views for reporting purpose. And what performance considerations did you take into account when designing these views, and how did you ensure they wouldn't impact the transactional performance of the underlying normalized tables?
We balance the performance and maintainability by optimizing indexes on drawing columns for views like V adoption summary. We use the schema binding for schema stability and examining the execution plans to identify bottlenecks, particularly in multi-table joins for more complex reporting needs. We consider the materialized views or scheduled generation of reporting tables during off-peak hours. This approach maintain our 3NF design while still providing efficient reporting capabilities.
Okay, that's very clear. Thank you for your answering.
Okay, thank you.
Any other question or comment for Team 1? Great work and presentation from Team 1. Team 1, your data analysis was complete and thorough. That's excellent. And your QA session was interesting. Thank you. Thank you, Team 1,
Professor.
and thank you for the question.
Thank
Thank
you,
you,
Professor.
Sure. Let's welcome Team 2.
Hello, Professor. We are Team 2. Let me share my screen.
Okay, thank you.
Okay, can everyone see my screen?
Yeah, you are on. Go ahead, please.
Okay. Hello everyone, we are excited to share our project with you today. We are Team 2 and our project is a database system for a physical bookstore. I'm Huijia and I will start by walking you through the background of our project and our goals and some key features. Our presentation is divided into 4 main parts. So let me start with my background. In many traditional bookstores, record like sales, stock, and suppliers information are kept separately and sometimes even on paper or in spreadsheets. This kind of setup makes it hard to track changes or make timely decisions. So our goals was to build an all-in-one database system and one that manages everything in one place. Book sales, inventory, customers, employee, and suppliers. With this integrated system, bookstore can improve efficiency, accuracy, and reduce repetitive tasks. So let me walk you through each of these 5 modules briefly. First, we have book management. We manage books, authors, and categories using books, authors, and categories tables to support to many relationship between books and authors. We use a bridge table called book authors. This design allows more flexibility in manage author book connections and classification. Next is the customers and orders. To track purchases, we use the customers, sales orders, and the book sales orders table. This setup allows each order to include multiple books. Additionally, we gather customers' feedback through the book reviews table, which provides useful insight for store improvement. So next move on the employee data protection. We store staff information in the employees table, and for privacy, we encrypted your salary using a field called encrypted salary. A secure decryption function is available when authorized access is needed, helping to keep sensitive data protected. Then we have inventory and alerts. The inventory tables tracks the quantity and threshold for each book. We store falls below the threshold. The record alerts table gets triggered to notify the store. We also use a book suppliers table to link books with their suppliers and the price information. Finally, our analytical wheels module includes wheel like popular books and customer purchase report and inventory management report and sales performance report. This helps the store managers visualize trends in sales, customer behavior, and inventory, making data-driven decisions easier. So with that over in mind, I will now hand it over to Peilin, who will walk us through the technical structure and the key relationships in more detail.
Okay, great. Hello, everyone. Before diving into the full ERD, here's a quick overview of the key entity in our database, categorized into core and additional entities. Core entities drive the main business process, such as books, customers, sales orders, and inventory and suppliers. Additional entities support operation, such as reporting, book reviews, and payment methods. We will see how they connect on the next slide. Huijia, please change to the next slide. Thank you. Okay, here's a categorized visual of the relationships in our database. On the left side, we show man-to-man relationships, such as books with authors, sales orders with books. We use tables to manage these relationships efficiently, and I will explain more on the next slide. In the center and the right, we show one-to-many relationships, like books to book reviews or payment method to sales orders. At the bottom, there's a one-to-one relationship between books and inventory, so each book has only one stock record. This structure keeps the design clean and supports basic logic and helps us avoid redundancy. As I mentioned earlier, we use join tables to handle many-to-many relationships. Now, as you can see on the screen, this is our full bookstore DBERD. We use colored coding to distinguish different type of relationships related tables. The yellow table, which book orders, book sales order, and book suppliers are traditional many-to-many join tables. They connect two main entities and use composite primary keys to ensure uniqueness. These tables are used purely to represent relationships and don't store business specific data. And the light blue table is inventory and book reviews. They are not joint tables, even though they contain foreign keys. Each serves its own business role. Inventory has a one-to-one relationship with books and manage details like stock quantity, reward thresholds, and the update time. Book reviews links customers and books, but also stores reviewed content like ratings and comments. So we treat both as business entity, not just relationship tables. We apply normalization principles to make our design scalable and consistent. Later, I will show how we inserted simple data to test these structures and support advanced features. And here's we focus on the three key tables: books, customers, and sales orders. In the books table, ISBN is unique and the category ID is a foreign key linked to the categories. Customers have unique emails and default values for loyalty points and the registration date. And sales order record quantity and the total price and link to customers' employees, payment method, and reports using foreign keys. To support this main table, we use join table like book authors, book sales orders, and book suppliers to form many-to-many relationships. We also include supporting tables such as authors, categories, and employees, and business-focused tables like inventory, book reviews, and rewarder alerts, which handle stock, reviews, and inventory alerts. Together, these tables form a well-connected system with foreign keys and constraints to ensure consistency and support the daily operation of the bookstore system. So, to make our design with extra data, we inserted sample records into 4 major tables. For example, we added 12 books, 12 orders, 10 customers, along with 10 sales orders. Additionally, our joint tables like book authors, book sales orders, and book suppliers, we populated to ensure proper many-to-many relationship mapping. All of the data help us validate for foreign key constraints, ensure table connectivities, and support later features like annexes and views. So now that we covered our database design and data populations, let's look at how we implemented advanced features like functions and views later.
Yeah, hi everyone. I'm going to introduce the advanced database features of our project. And let's begin with the function-based check constraint we implemented for ISBN validation at the database level. First, we created a custom function called isValidISBN. This function checks whether the input string follows the basic pattern of ISBN 10 or ISBN 13. If it doesn't meet either of those standards, it returns 0, an invalid ISBN. And next, we added a check constraint named checkValidISBN on the books table, which calls this function whenever someone tries to insert or update a record with an ISBN that fails the validation, the database will reject the operation. So in this way, even if a front end lacks proper validation, the database itself will still prevent incorrect ISBN data from being recorded, significantly improving data quality. And next, let's see function-based computed columns, a powerful feature that allows the database to automatically calculate derived values. We implemented two key computed columns, book age and inventory status. First, the calculate book age function calculates the year since the book was published. And then we apply this function to the book table. This way, the database automatically calculates books age with every query. No need for repetitive calculations in your application code. And as you can see on the screen, Pride and Prejudice is now 212 years old. Similarly, we created the isStockLow function to automatically monitor inventory status. This computed column allows us to instantly identify books that need restocking. As shown in this image, War and Peace with only 5 copies in stock below the threshold of 7 is flagged in low stock. These two computed columns greatly simplify business logic and ensure data consistency. And the next is the column level data encryption we implemented in the database. First, we use a 3-layer encryption architecture. The first is master key, protected by a secure password, serving as the root of encryption within the database. And the second one is certificate, created from master key and used to encrypt the symmetric key. And then is the symmetric key, utilizing AEI's 256. It handles the actual encryption and decryption of sensitive data, such as salaries. In the employees table, we added an encrypted salary column of type var binary to store the ciphertext. Then we use encrypted by key in an update statement to transform plain salary values into encrypted data. As a result, even if someone views this column directly, they cannot see the true salary without the decryption key. And to retrieve the original salary, we must open symmetric key and apply decrypt by key. We also created a secure view, which calls our custom function get decrypted salary. Only when the symmetric key is opened when the view will return the real salary values. Otherwise, it is null. This approach significantly protects sensitive information and preventing unauthorized person from accessing employees' real salary data. It aligns well with higher security and compliance requirement. And the next part is about the business views we created in our database. Each view looks at the data from a different angle to support the bookstore's daily operation and decision-making. First is popular book, combines essential book information, sales data, rating, and the inventory status into one result. It helps us identify best-selling title that may be in high demand or low on stock. And column like total sold and average rating allow marketing teams to see which books need promotion or restocking. And the second one is customer purchase report. Focus on customer behavior by summarizing each customer's total spending, number of orders, and date of last purchase. This is crucial for membership segmentation and targeted marketing strategies. For instance, identifying top spenders or customers who have not purchased recently. The next one is inventory management report. Shows detailed inventory data, including current stock levels, whether a book is below the reorder threshold, and the status of recent reorder alerts. This helps warehouse staff quickly identify which book urgently need restocking, preventing out-of-stock issues. And last one is sales performance report. Aggregate sales order by employee, time period, and category, calculating metrics like total revenue and average order revenue. This is especially helpful for evaluating employee performance and seasonal trends. On the technical side, these views are created by joining important tables like books, sales orders, book reviews, and inventory, and by using basic calculation. For example, popular books adds up total sales and average rating. Other views follow a similar approach, each focusing on a different type of information. By using these views, we make it easier to work with data and get ready for the next step, building charts and reports. This makes bookstore database much better for tracking and understanding the business.
Hi, now let me introduce you to the visualization part of our project. We use Tableau to implement this part, and all data is sourced from our 4 view functions we created. We'll start with book performance. We looked at the top 10 best-selling books and the revenue distribution by category, and this helps us decide which books are more popular and which slower sellers might need promotional support. For strong performing category like fiction, we could expand the selection to drive more sales. And the second part continues with book insights. We compared rating with sales and find that some highly rated books are actually underperforming, and promoting these underrated books could increase both revenue and customer satisfaction. We also analyzed customer spending versus average rating to track how happy our top spender are and identify ways to improve their experience. And next is customer behavior analysis. We ranked customers by spending to identify loyal, high-value users. We also broke down sales by membership level, like gold, silver, bronze. We can also get the number of every membership level, and this allows us to create exclusive campaigns for them and encourage upgrades for other levels. And then we also analyzed the sales performance. We visualized the monthly trends for like planning, promotions, or events. We also have employee level performance. It helps us find the strong performers for rewards and notice who may need support or training to improve our service. And the last one is inventory and suppliers cost analysis. By comparing stock level with sales, we could notice some hot selling books might run out soon, while others are overstocked. And by checking average supplier price, we can better manage procurement costs and profit margins. So for our project summary, we built a comprehensive bookstore management database with all major entities and relationships. We added data validation, salary encryption, and custom psychologic. Then we created analytical views to support key areas like popular books, sales, customers, and inventory, and used Tableau for clear and actionable visualization. And the system is also designed with scalability in mind. So we also consider the future development. we are planning to support an online bookstore, including features like online orders, digital books, logistics, user accounts, and personalized recommendations. We also want to implement a real-time dashboard for quick decision-making, automate low stock alert, and analyze customer behavior to power smarter marketing and better management. Okay, that's the overview of our project. Thank you for listening. We're happy to take any question now. Thank you.
Okay. Thank you for your presentation, and I have a question about the encryption part. Like, does the encryption functionality impact your system performance, and why do you use symmetric encryption?
Encryption does add computational overhead, but we only encrypt sensitive fields such as employee salary. Yeah, so the impact is limited and manageable. And also we chose symmetric encryption AES 256 because it's more efficient with processing large volume of data. And also SQL Server provides built-in symmetric key management infrastructure. Yeah.
Okay, thank you.
No problem.
So my question is, how specifically does data virtualization help to improve the business performance in your bookstore DB system?
Thank you for your question. I think our 4 view functions can provide a lot of important business insights. For example, we have popular books. We can get the best sellers and the lower sellers, so we can expand the shelf space for like best sellers and do more promotion for lower sellers, and which can help us increase our sales and clear inventory. And we also have a customer dashboard using our customer report, and which can identify high value customers for like our targeting marketing. And then we can also identify our employees with low performance and organize some training sessions to improve their services. Thank you.
Thank you for the answer. Thank you.
Thank you.
Any other question, comment for Team 2, please? Okay, Team 2. Overall, your project and the presentation were very solid and outstanding. And I really like your slides. Thank you for the great work and the presentation, Team 2. And thank you for the questions. Let's welcome Team 3.
Hi, Professor. Let me share my screen.
Yeah, okay. So probably Team 2.
Oh, yeah.
Team 2, yeah, please stop sharing your screen.
I still can't share my screen because they're sharing.
The Team 2 is trying to stop sharing.
Okay.
So let's just wait a second, please. Okay, thank you, Team 2.
Thank you. Good morning, everyone. I'll be doing the introduction for Team 3's project entitled Course Enrollment System. Our presentation.
Hold on, could you put your slides in the presentation mode?
This is not the presentation mode. I'm sorry. Let me check. It's now okay.
It's still, you could probably just focus on one slide that you are talking about. Now,
Okay,
I think
okay.
this is the design mode.
Okay. Let me stop. Is now okay?
Oh, yeah, excellent.
Okay, I'm so
Thank you
sorry.
for doing this. Yeah.
Thank you. Good morning, everyone. I'll be doing the introduction for Team 3's project entitled Course Enrollment System. Our presentation will walk you through the introduction, the ERD, which outlines the database architecture of the system. Then we will explain the key tables and how the core features are implemented in code. After that, we will present visualizations to give a clear view of some features. And then we will wrap up with a summary followed by a Q&A session. This system is designed to support the entire course enrollment process at an academic institution. There are two types of users, students and instructors. For students, we have a student management module. It enables them to register an account, log in, update personal profiles, browse the list of available courses, and register courses. For managing course information, we built a course management module. This allows the systems to store detailed course data, enforce capacity limits, and classify courses by credit level or subject. And for instructors, they can view the courses they are assigned to and enter or update student grades throughout the semester. To make enrollment efficient and fair, we implemented an enrollment process module. It helps the students select courses based on semester, credit level, or subject, and places them on a wait list if the class is full. Lastly, we included a visualization module. This gives a clear overview of students' basic information, enrollment details, academic performances, and etc. Now let's talk about the business problems we addressed. One major challenge in course registration system is fairness and capacity control. We implemented a full queuing and waitlist mechanism, which prioritizes students and ensure a fair enrollment process. We also solve the complexity of scheduling by modeling many-to-many relationships between courses and time slots, supporting multiple sessions per course. To secure the system, we applied symmetric encryption with certificates and a master key to protect both students and instructor accounts. Lastly, we built a fully connected and consistent data module that links courses, instructors, semesters, schedules, and enrollments, ensuring seamless integration across all entities. Next, I will hand it over to Liang, who will explain the data architecture in more detail.
Now let's talk about the database architecture. The next slide. So, all right, so we are looking here at, here is the entity relationship diagram. Basically, the blueprint for the whole student course enrollment systems. We have got 12 different tables, all connect together to handle everything from student registration to the cost management. See how we have mapped up all these connections between the students, course, instructors, and everything else. We have used different types of relations, like one-to-many and many-to-many, to mirror how things actually work in a real college or university. Think of this diagram as the foundation of our entire system. It may look a bit complex at first glance, but each connection serves a specific purpose to make sure our enrollment process runs smoothly. Let me walk you through some of the most important parts of our design. Next slide. Let's talk about the heart of our system, the 5 main entities that make everything work: student, course, instructor, the enrollment, and the waitlist. And next slide. The first up is enrollment tables. This is really the cornerstone of our entire system. It's what connects the students with their course, which is what this whole project is about, right? When a student signs up a class, we create a record, and later we add this grade when they complete this course. Notice how these tables connect the 3 different entities: the students, the course, and eventually the grade they received. It's like the central hub that ties everything together. Next slide. We have the student table, and this is where we keep our students informed: their name, email, and which major they are in, and so on. Here's how we build it. Don't worry too much about this syntax. The important thing is that each student gets a unique ID, and we track their basket informed plus which major they are enrolled. Then we got the course table. This understood everything about class, who teach it, which department they are in, and how many credits it's worth, and importantly, how many students can take it. Next slide. So we also have the instructor tables, pretty straightforward. This keeps the track of all the faculty members and which departments they belong to. Finally, we have waitlist tables. Anyone who has been to the college knows the frustration of trying to get into a full class. Our waitlist systems manages the queue for the students waiting to get into the popular course. So these 5 entities work together and are like a well-oiled machine to handle the whole enrollment process from the start to the finish, with the enrollment tables served as the central connection point for the entire system. Next slide. Now, let me show you some of the key design decisions we made to make sure our database is rock solid and secure and easy to maintain. The first, we use we code and third normal form, which is basically a fancy way of saying we organize our data really efficiently. Instead of repeating the same information over and over, we split things into logical tables. For example, we have a separate department and major tables, instead of duplicating the department inform for every major. We also created special tables called associated entities to handle the many-to-many and relations. A good example is our course prerequisite tables. Since one course can have many prerequisites, and one course can be the prerequisites for the many other courses, we need these and middle tables to connect them. And security was the bigger priority for us, so we implemented the password encryption, use this symmetric and keys. This means that even someone somehow gets access to our database, they couldn't see the actual password. For our waitlist and systems, we add a priority field to make sure it's failed, and first come, first serve. All these design decisions make some technically, but they are what make our system reliable and secure and built to the last. So this covers the foundation of our database. Now to show you some of the cool functions we built on the top of this structure, I will hand it over to Jocelyn. Next slide.
So in this section, I'll walk you through some of the key logic and the functional components in our system, including the registration procedure, computed columns, data validation functions, and the reporting views that support our dashboard. Next slide. So let's start with the registration procedure. We designed a store procedure to handle course enrollment and waitlisting in a controlled and consistent way. The logic begins by checking whether a student is already enrolled or already on the waitlist for a given course. Then it verifies that the course exists and checks how many students are currently enrolled. If the seats are still available, the student is enrolled immediately. Otherwise, if the course is already full, the student is placed on the waitlist as long as it hasn't reached the limit of 15. If both the course and the waitlist are full, the transaction rolls back and returns an error message. Next slide. This slide, we can see the actual SQL implementation. First, we wrap the entire process in a transaction use begin chance and finalize it with either commit or rollback. This ensures atomicity, which means the registration either fully succeeds or fails without potential changes. We also use if exists to check the duplicates, and we count enrolled and waitlist students dynamically before making any decisions. Next slide. To simplify the data model, we create two help functions. The first one, format full name, takes a student's or instructor's first and last name and combine them into a full name. It's used as a persistent compute column, which improves the performance. And the second function is course level. This categorizes each course as basic, intermediate, or advanced based on the number of credits. This makes it easier to analyze course levels in views. Next slide. Next slide, please. Okay. We also implement two validation functions to enforce business rules directly in the database schema. The check capacity ensures that course capacity is between 5 and 100 students, and the check grade points validates that grade points between 0 and 4. These are applied using check constraints on the course and the grade tables. This adds a second layer of validation, ensure that only valid data is accepted, even if the front-end validation is skipped. Next slide. We created 5 SQL views that each focus on a different aspect of the data. These views help us summarize and transform complex join logic into a reusable and readable result for reporting and visualization. So let me walk through each of them. Next slide. So the student basic info view combines student personal information with their major and department details. The department course summary provides an overview of each department's course, including account and a concatenate list of course names. The enrollment details joins multiple tables to present complete information about the students' enrollments, including course details, instructor names, and the grades. Next slide. The course schedule details gives comprehensive timing information about when and where the course are held, including day of week and time slot. Finally, the course registration status shows real-time information about course capacity, enrollment count, and the remaining seats, with a status indicator showing if the course is open, full, or closed for registration. Together, these 5 views serve as the analytical backbone of our system, powering both reports and visual insight. Next, I'll hand it over to Ekta to cover the visualization section.
Thank you. So now let's explore the visualization components of our course enrollment system, which was done using Tableau tool, using the live connection, which allows real-time access to the latest data. These visual aids play a critical role in translating raw data into actionable insights for the users. Next slide, please. We start with a packed bubble chart and a heat map to represent department-level insights. The packed bubbles illustrate the number of courses offered per department in an engaging and space-efficient manner. The size of each bubble indicates a number of enrollments. Larger bubbles means larger students enrolled. Different colors represent different departments, giving a visual cue on the different department popularity and reach. This helps stakeholders instantly grasp which courses or departments are overloaded or underutilized. Meanwhile, the heat map identifies a department with higher or lower course activity based on enrollment numbers or availability, making it easier to detect trends or imbalances. The rows are the departments, and the size of the square shows how many courses were offered. This gives insight into department level teaching loads and curriculum breadths across time. Next slide, please. Next, we use a Gantt style chart to represent the course schedule. This visualization allows both faculty and students to view the course timings across days, weeks, helping them to avoid conflicts and better plan their academic workload. On the x-axis, we have the start time of each course, while the y-axis denotes the course name. The length of each bar represents the duration of the class in hours. We have color-coded each bar by instructor so that you can clearly see the scheduling overlaps or workload distribution. This helps prevent scheduling conflicts and optimize instructors' assignment. Next slide, please. Next, we see horizontal bar chart. This allows the academic staff to monitor courses demand in real time, balance the registration across sections, and make timely decisions like opening additional sessions or increasing the waitlist capacity. On the y-axis, we see the list of courses offered for a particular semester. On the x-axis, we show the number of seats visualized using horizontal bar. The first chart shows the remaining seats of different courses with different colors depicting the different semesters. The second chart shows the course names with the registration status, their semester names, their capacity, and their enrolled numbers. There are filters on the semester name and registration status, which helps you to filter and pick the data which is needed by the stakeholder. The KPI view chart displays the total filled rate percentage as a performance metrics, which is the percentage representation of the total enrolled students on the total capacity. Next slide, please. Finally, in our last visualization report, we complement the course data with the enrollment details of the students. The line chart helps to analyze the enrollment activity over time, which is useful for understanding the peak registration periods. A trend line across quarters show how enrollment evolves over time, and this allows us to detect seasonal trends and align resource planning accordingly. The two tables displayed shows the student, their courses, their grade information. Color coding is applied to grades and the courses for quick differentiation. These visualizations together empower stakeholders to make different data-driven decisions, optimize scheduling, and improve the overall user experience within the system. Now, I'd like to pass it to my peer, Coulson, for summarization.
Okay, thank you. Thanks to my teammates for their excellent explanation on our project and how they did that. And also, I want to say thank you for joining us today as we wrap up our project on the student course enrollment system. And I'm Coulson, and I'll be taking you through the key takeaways and future directions of our project. So let's begin with a brief recap. Next slide, please. Okay. Our primary objective was to create a centralized, efficient platform to manage all aspects of course enrollment. The system is designed to simplify student registration and ensure accurate data management and support both instructors and administrators. It addresses challenges such as accurate student information management, prerequisites enforcement, and handling course capacity with waitlists. And next slide, please. In this slide, we see the core building blocks of our system, and we have defined entities such as students, courses, instructors, and more. By establishing strong relationships using primary and foreign keys and following certain normal form guidelines, we ensure that our database minimizes redundancy and maintains data integrity. The use of the associative entities like course prerequisites and course schedule lets us model many-to-many relationships effectively. And moving to next slide, the implementation details. Our SQL scripts cover the full lifecycle from creating our database and tables to inserting a minimal set of 10 rows per table. We enhance the design further by incorporating advanced features like table level check constraints, computed columns, and column data encryption for security sensitive information such as passports. Additionally, we developed two views, which help in generating insightful reports about student enrollment and course details. And next slide, we will be covering the impact and benefits here. So the impact of our solution is significant. Operationally, this system streamlines the enrollment process, enhances security through encryption and role-based access, and offers powerful reporting capabilities. From a user's perspective, it provides an intuitive and efficient interface for both students and instructors, making everyday academic processes smoother. And next slide, please. The future enhancements and learnings. Looking ahead, there are a number of enhancements we could consider, including further automation of reports and scalability improvements. This project has provided valuable lessons on the importance of database normalization, the efficacy of integrity constraints, and the potential of advanced SQL features to solve real-world problems. And yeah, And next slide, please. Yeah. In conclusion, our student course enrollment system is a robust, secure, and efficient solution for modern educational institutions. And I'd like to thank you for all your attention. And now I'd be happy to answer any question you may have. And yeah, please hit me with questions if you have any and want to know more about our project.
Okay. I have a question. Can you hear me?
Yeah, perfectly.
Why did you choose to separate major and the department into two different tables?
Yeah, for sure. That's a great question. So I want to first start with the separation of why we did the separation of major and departments into like distinct tables, because this reflects the fundamental differences in their roles and responsibilities within the university structure. And the department table represents a broader organizational unit that manages administrative functions, including the assignment of instructors and oversight of courses. In contrast, the major table is focused on the academic programs that students enroll in. Since each major is typically governed by one department, storing them separately achieves normalization, maintainability, and flexibility. So that's the reason why we choose to separate them.
Oh, okay. I think it's very clear. Thank you for your answer.
Yeah, of course. Thank you for the question.
Can you hear me? I also have a question.
Yep, perfect and clearly.
Yeah. Which view do you think is most valuable for like administration users and why?
Perfect. Thank you for the question. So which view do we think the most valuable? Okay, so I would say the course details view is particularly valuable for administrative users. So this view aggregates critical information such as course information, including course names, credits, and capacities, and also the scheduling, the details on when and where courses are held, as well as instructor assignments, which instructor is teaching the course. So this consolidated view provides administrators with a comprehensive snapshot of course offerings. It enables them to easily identify trends, manage schedule conflicts, and assess workload distribution among instructors, and also address a potential capacity issue quickly. So by having all these key elements in one view, decision-making becomes faster and more informed, ultimately leading to a more effective academic and operational planning. So I think that's the most valuable one for administrative users. Yeah. And yeah. And I think that's pretty much our presentation look like. And thank you again for your attention. And yeah.
Great work. And sorry about interrupting.
No, this is Team 4. Yeah.
Okay. Do you have any other question or comment for
Sorry.
Team 3? Great work and presentation from Team 3. Team 3, your implementation was great. And I like your views and the data analysis.
Thank you, Professor.
Thank you. Yeah.
Thank you
for the great work and the presentation. And thank you for the questions.
Yeah.
Let's welcome Team 4.
Okay, this is Team 4. Can I share my screen?
Yeah, go ahead, please.
Okay. Okay, can you see our slide?
You are on. Go ahead, please.
Okay, thank you.
Hello everyone, my name is Rongnan and I'm from Group 4. Today I'm here with my teammate Ting Hao, Shiyin, Haolei, Chenglong to present our final project, the book inventory management system. To start off, I would like to give you a brief introduction of our project. We developed our book inventory management system, which purpose to have the business efficiently check, manage, and optimize their stock levels. Can you take next slide? The system provides the real-time insights into the inventory status and trying to help the business reduce the operation costing, enhance the customer certifications. We hope the system is not only focused on the basic information, like book recording, customer information, or sales detailing, but also can provide some valuable marketing insights to support the better business decisions making in the future. And next, I will talk about the main problems our system to purpose to solve. Next slide, please. So first, we have the inefficient inventory checkings, which could be avoid the overstockings due to the inaccurate recordings. Next is the poor order management. When orders are checking manually, it could be late to error or delayed. Other major issues is linked to the customer insights. Without the ability of efficient collect or analyze the customer data, the business cannot understand what is the preference to make through the data-driven decision and based on the product. We also face the limitation reporting capabilities. The real-time insights into the sales expense and the revenue trade are crucial for informal decision-making. The security concerns are also a big risk for us, and also the access to the sensitive data, it could be lost to the serious breach. And finally, we always pay attention on the scalable issues. As the business or organization grows, the system must be available to handle the large inventories and increase the increased user loading. To address those 6 main issues, we designed the database system. And also, I'm gonna pass next slide to Chenglong, and he's gonna continue to talk about the entity relationship background.
Okay, now I'm going to introduce our ERD. This ERD represents the database design for a book e-commerce platform aimed at solving key business challenges such as inefficient inventory tracking, poor order management, lack of customer insights, and limited scalability. And at the core of the design, we separate books into 2 levels, book group and book. The book group entity holds shared metadata like title, author, and genre, essentially representing the conceptual book. And meanwhile, the book entity tracks individual physical copies, enabling precise inventory control and order fulfillment. Inventory is managed through the inventory entity, which tracks available stock and links to one or more suppliers. And this structure allows us to maintain accurate stock levels and manage supply relationships efficiently. And the order and order item entities form the backbone of the transactional system. Each order is placed by a customer and includes multiple order items. And these order items are linked directly to specific book copies, allowing for detailed tracking of which physical items were sold, in what quantity, and at what price. And then user management is handled through the account entity, which abstracts the identity of a system user. Each account is associated with either a customer or an employee through a many-to-one relationship. And this setup allows us to manage authentication and roles efficiently across different types of users. And then for user feedback, the review entity allows customers to rate and review books. Reviews are associated with book groups rather than individual books, since users typically review the content, not the specific copy they received. And in terms of analytics and reporting, the model supports essential relationships such as genre classification, order history, and customer reviews. And this structure provides a strong foundation for business intelligence and future growth. So overall, our ERD emphasizes clean separation of responsibilities, clear relationships between entities, and a scalable foundation that can support both operational efficiency and data-driven decision-making. So now let's move on to the next part.
Okay, this is Ting Hao, and I will continue with the view created from our database. And first view is designed to provide detailed book information by combining multiple related tables, and enjoys the book group, author, genre, and inventory table to show comprehensive information about each book. And for each book, it displays the title, author, name, genre, price, and the quantity in the inventory. And this view is especially useful for generating product detail pages or managing the book catalog in an unmanned dashboard. And yeah, this is the outcome of the view, and you can see the title of each book and what their who their author is and their genre and their price. And you can also know the quantity of each book in the inventory. And the second view is mainly built to support user feedback analysis and admin reports. And it connects customer account and review tables to provide a full picture of each customer's identity and their reviews. And with the view, we can easily generate reports showing all customer reviews, including their names, account names, ratings, comments, and review dates. And it also helps link login data from the account table with customer feedback, which is useful for building admin dashboards or doing sentiment analysis. And in this view, you can also add the condition on it. For example, we add the rating. We want the rating greater or equal to 4. And the outcome you can see the rating is all greater and equal than 4, and we can see who the customer's name who add the review on and their account name and what their content of their comment and when they add the review on. So next slide.
Yeah, hi everyone. In this section, I will introduce one of the core database features in our system, the computed column, specifically used for calculating the average book rating. Yeah, in our book inventory management system, we create a computed column using the SQL average function. This column calculates the average rating for each book based on submitted reviews. And now, instead of running queries every time we want to know a book's performance, the system keeps this metric updated automatically. That means whether it is the admin browsing the dashboard or a user looking for a top-rated book, the average rating is always real-time, consistent, and accurate. We also implement a non-value checking. This means rating that are missing or improperly submitted are filtered out, so they don't distort the average. And from a business perspective, this is pretty crucial. Misleading average can hurt both sales and trust. And the result is a smoother experience. A customer can sort or filter box based on true ratings. And meanwhile, the admin team can use the average rating data to promote top performing titles or investigate poorly related ones, all without extra engineering effort. And this design not only improves usability, but also contributes to system scalability. As reviews increase, we don't need to rework our logic. The database handles it seamlessly, and keeping performance optimized. Next slide, please. Yeah. Now let's look at another important but often overlooked feature, that is constraints, and how they keep our system safe and clean. And in our system, one example is the account links constraint. We added a rule that requires all the usernames to be longer than 5 characters. Simple, right? But it plays a major role in ensuring data quality and security. Because short and generic usernames like ABC or like 1234 are not harder to manage, but also increase the risks of collisions and misuse. And by enforcing a minimum length, we reduce those risks and encourage better naming conventions. From a technical perspective, constraints act like a safety net. Even if something slip through the front end, maybe let's say a bug or a missing validation, the database still rejects invalid data that ensures our records stay clean and reliable. This is especially important when scaling. As the number of user grows, even a small percentage of bad data can cause huge downstream issues in analysis, bug user lookup, or even customer support. And constraints give us confidence that our system enforce strong rules at the core level, not just on the surface. They improve trust in the system and simplify the future maintenance and keep the business running smoothly. In short, both computing columns and constraints might look like small features, but the fundamental to building a resistant, efficient, and scalable database system. Next one is Tony.
Okay, and the next part is the book review performance report. The first one is the review volume trends between April 2023 to April 2024. The first visualization shows a clear pattern in review activity over a 1-year period. And first, we can see in the chart there is a consistent performance between April to October 2023. That is to say, reviews maintained a steady range between 75 to 87 per month. And then we can see the peak performance period. The two notable peaks occurred in December 2023, and the other one occurred in February 2024. And this one also representing the highest activity point with 103 reviews. And then we can see there's a significant decline. There was a dramatic drop in April 2024 with only 2 reviews. And this also means there's 98% decrease from February, the highest peak point. And next slide. The next one is the book group performance report. And this chart shows the review distributions across 10 different book groups. First, we can see the top performing groups. The top 3 performing groups is Group 6, Group 4, Group 10. And Group 6 is the highest with 116 reviews. And then we can see the lowest performing group was Group 3 with 82 reviews. And for the other mid-range performance, like Group 1, 5, 8, 9, They are all clustered around 90 to 94 reviews. And with these two charts, we can have some conclusions. The first one is the seasonal patterns. We can see the highest peak point occurred in winter, the December to February period, and the lowest peak point occurred in the spring, in April. And then we can see there's a dramatic drop in April 2024. So we need to pay attention to this and take a look what's happening in April to cause this sudden drop. And then we can see there's a 41% difference between the highest and lowest group. And it shows the performance gap. And that's one, we can see the relationship between the consistency and variability. Monthly reviews patterns show significant variability, range over 100 between the highest and lowest month, while the book group performance is way more consistent, range just 34. And here's our presentation. So anyone has a question?
Yeah, thank you for your presentation. It's very good. I have a question. Could you share what was the biggest challenge you faced while working on this project?
I would say because the you can see the book and the book group table, and in this question we have to divide because each book has their own ID, so we have to divide two tables of the end. First, we are confused about the book with same name and same author, maybe same contents, is same book or different book. And after all, we determine to divide to two tables, which is one is book group, which means is the copy of each book, and one is book, which the content of it is the ID of each book. Then we can know that even the book have the same content or same author, then they are different. And I think this is the big confusion first. We create this table.
Okay, thank you. I have another question. So if you had more time, how would you improve your database, you think? Design.
I think if we have more times, we will collect more data because I think for the report, we have enough data to figure out the pattern of the customers or the other things.
Okay, thank you. I think that's all I want to ask. Thank you.
Thank you for listening.
Yeah, that's all our reports. Thank you.
Great work and presentation from Team 4. Thank you, Team 4, and thank you for the questions. Let's welcome Team 5.
Can everybody see my screen?
Yeah, you are on.
Okay, thank you. Thank you. So hello everyone. This is group 5. So I will be the first speaker today. I will begin with introduce our team project, which is a library management system. This project was developed as a part of our course. And the goal here was to build a digital platform that supports the essential day-to-day functions of the modern library. So what's exactly of this project about? This library management system is a database-powered applications that helps manage all the key activity that happens in a library, things like keep tracking of the books, users, and staff, and also handling process such as borrowing, returning, making book requests. The main idea behind this system is to streamline library options digitally, reduce manual work, and make sure that both students and the library can use the system easily and efficiently. Now, when we talk about users, we had two main groups. First group is the students. They can borrow and return books, also leave reviews and request a book they like the library to add. Second group is the library staff. They can manage a book inventory and handling loan and return process. Also keep an eye on user activity. For the tools we use, we build a database using CQ, and we also use ERD diagram to map out our data model. And for data visualization, we use Tableau. Those tools were chosen because they're widely used in real world and are great for working with structured data. Overall, this is a project that shows our understanding of a key database design principle, things like normalization, integrity, and scalability, and put them to use in real life context. So that's a quick review of our project. Now I will pass to the next speaker, Francis. He will introduce the core function of our project. Thank you. Francis?
Hi, everyone. So today I'm going to be talking about the core functionalities of our library system. So first of all, we have what I believe is one of the most pivotal parts of our system, which is the book management. And through the book management, here we can actually add, remove, and update book information. For instance, this could be the names of the titles or the ISBN. Then we can also check if the books are actually available. Then secondly, we have user management. As Jinxie had mentioned, we mainly have two users we are focusing on, which are the students and the staff. So here we can now update their information, such as their names and their emails. We can also track their activities. So this helps with checking about penalties or even requests. Then thirdly, we have staff management. Through the staff management, here we can have vital information such as their names, their emails, and their employee IDs as well. And we can also look at who has access to handling certain operations about the loans and who can actually manage book requests as well. Then moving on to the fourth one, which is the loan management, which is also quite important as well, because here we can now see which books have been loaned out and which ones are actually available. And staff members can also be involved in this system to ensure that proper tracking of the books is maintained. Okay, next slide, please. Okay, then here we also have one which is also important, the penalty management. Like for most of us who have had access to a library, we know that if, for instance, you don't return a book in time, there'll always be a penalty. So here, it's also important to make sure there's a system in place to ensure that records about books which are overdue can be easily accessed. We also
make sure that we track the penalty amounts, and we also check if the payments have been made as expected or if there have been delays. Then we move on to the review system. The review system is there in place so that users can rate, and they can also leave comments about certain titles they like or titles they dislike. And here we can also see that each book can have multiple reviews or multiple comments. Then we move on to the book request and library request. This gives our users a chance to request certain titles they would want. They can use different ways to request this, maybe through the title, through the ISBN, or even through the name of the author. Then last but not least, we have the categorization and the searching functionality. This one's also quite essential because here we can now make use of filters, which helps the users to actually filter out and look for certain titles and books they want. And through the filters, they can, perhaps if someone knows about the ISBN, but they don't know about the title, or if they only know the title, this functionality actually ends up helping users to be able to search for a certain book using only the information they have. Thank you.
Okay, so I'm going to be talking about the design concepts of this database and their architecture. So we wanted, for normalization, we normalize it to the third normal form, so that way we don't have any multiple to multiple, like many to many relationships, and also just to avoid the redundancy by splitting the data into multiple tables. Then we enforce primary and foreign keys to enforce the data integrity and unique values. And for scalability, we really wanted the databases to be able to be scaled upwards as the library system would scale in real life. So this way that the database is going to support future additions such as different entities or columns such as ebook or various book like states or various book which are like formats, and also securities to limit access through roles, a user versus staff. This we enforce by having a check table, a check constraint where users their email addresses can be anything like Google, Yahoo, Outlook, but the staff library email addresses are a specific like have a specific email format. That way we can separate the users versus staff. Next slide. From there, here are some breakdowns of the design decisions that we made. I'm just gonna give a high level overview. So obviously for books, we wanted to include that entity since it is the main entity and it is related to other entities, mainly author, genre, and publisher, and shelf location to really have that filter ability for users to have. And also having the relationships so that the users can check out books using book requests. Author is another way for users to filter by book and also categorize the books as well. And same with genre. This is categorizes the books by their subject or the theme, and it helps users another filter feature, and it is linked to books via the genre ID, meaning that like multiple books can belong to the same genre, and make sure that these books are classified correctly. Next slide. Really quick, same with publisher and shelf location. These are also filter, like ways that the books can be filtered. User is another main entity, so that represents a user in the library system. They can borrow, review, and request books. And this is like essential for managing the requests and penalties. Loan is the actual loan from the library, and it tracks which books are being borrowed by which user and when they are due as well. Book request, it allows the user to request the book
that is unavailable, and it helps the libraries track the demand for the books. And also a library request, this is for books that aren't in the system that a user may request to the library. And it helps assess like what new books should be like acquired based on demand. Next slide. Wait, can you go to the next slide? Okay, so reviews, it's like kind of like a Yelp function. Oh, before one more before. Yeah, it gives the user the rating and reviews to help others decide what to read, and also what needs to be popular. And then also, the one is the fines for the loans. It tracks the overdue books, and also the staff entity is just the librarian to manage book loans requests and the general library like operations and accountability for transactions. So I will pass it on to the next speaker for entity relationship diagram.
Thank you, Carly. So, hey everyone, this is Sohita, and I will be talking on the ERD diagram. So, on this slide, we are presenting the entity relationship diagram for our database system. The ERD is the blueprint that shows how the different parts of our system are connected and work together. So here's our ERD diagram. Before diving in, just a quick note, we decided to keep everything on one slide. That way you can see all the tables and the relationships together without flipping back and forth. So at the core of the system, we have two major entities, users and books. Users are the people interacting with the library. They can borrow books, leave reviews, request new books, and sometimes incur penalties. Books, of course, are the primary assets the library manages. And the loan stable connects users and books. Whenever user borrows a book, a loan record is created, capturing important information such as the borrow date, the expected return date, and the actual return date. This relationship ensures we can easily track which books are currently out, which have been returned, and which users might have overdue. Next, we have a staff table. Staff members oversee various operations like approving loans, managing book returns, and handling book requests. They play a crucial administrative role in maintaining the library's smooth functioning, and their activities are linked directly to the loans and book request tables. The system also handles reviews after reading a book. Users can provide feedback, which is sorted in review table. Each review is linked both to the user who wrote it and to the book being reviewed, creating a clear trail of user experience and feedback for each book. In cases where books are returned late, penalties are generated. Penalties are associated directly with specific loans and users. Our system automatically calculates overdue days and assigns the corresponding fine, which can later be paid or left outstanding. Beyond basic borrowing, the database keeps the book catalog highly organized. Each book is associated with a author, a genre, and a publisher and a self location. These relationships allow for powerful features like filtering books by genre, finding all books by the same author, managing inventory locations, and analyzing publishing trends. We intentionally designed the system using normalization principles, which means separating the data into distinct tables to avoid duplication and ensure data integrity. For example, instead of writing the author's name repeatedly for each book, we reference the author ID, ensuring the author's details are stored once and updated easily if needed. The overall goal of this design was to create a system that is flexible, scalable, and easy to maintain as the library grows larger. It supports all the core library activities from borrowing and returning books to reviewing, requesting, and even paying fines while keeping the data structured and efficient. So I'll pass on to Stevia for data visualization part.
Thank you. Okay, so the first chart that we see, it shows the top 10 most borrowed books in our library system, ranked by the number of times each title was checked out. So as we can see, the Handmaid's Tale leads the list, followed by Pride and Prejudice, 100 Years of Solitude, and multiple entries of the Harry Potter series. What's interesting here is the clear dominance of classic literatures and fantasy fictions. This tells us that the users are drawn to immersive storytelling, familiar authors, and well-known series. Titles like Harry Potter appears more than once, likely due to the multiple copies or strong ongoing demand. It is worth noting that the diversity of genres, we have historical fiction, mystery, and modern fantasies all within the top 10. This could inform future decisions about purchasing more copies of high demand books, creating genres based on displays, or promoting lesser borrowed titles that aligns with these interests. Next slide, please. So in this slide, this is a line chart, and we track the number of books borrowed across 3 months, so January, February, and March. While the numbers are relatively stable, we gradually see increase. So we see 14 loans in January, 14 again in March, and 14 in February, and then we have 15 in March. And this may appear subtle, but it's a positive trend showing steady user engagement. It could reflect users returning from holiday breaks, new semester reading routines, or increased participation in reading programs. If we were to compare this to other quarters or the same time last year, we might identify seasonal borrowing patterns. Understanding these patterns can help our library better plan time promotions, prepare staff, or schedule events like drive borrowing. For example, since January has the consistent activity, it could be an ideal time for a New Year reading challenge or to introduce new arrivals. So altogether, these virtualizations offer insight in users' perspective and behavior. The most popular books helps us to understand demands, while the monthly borrowing data helps us to track engagement trends. And by analyzing this information, our library system can make smarter decisions around acquisitions, user outreach, and programming to better serve our readers. And we're passing it on now to Carly again.
Yeah, so some suggestions for further database design. One would be an entity for a branch, just to simulate different branches of the library system. As you know, in like real life, there like one library system can have multiple different branches based on neighborhoods, and we would like to add this just to be more granular with the data to see what branches have more active users or which books are more popular at a certain branch versus throughout the entire library system. And this branch would have, this entity would have the branch ID as a primary key and would be added to staff, book loan, and the book request table as a foreign key as well as users. As explained below. So then another one would just be add book format to book to designate the type of books to accommodate for different book formats, because in this day and age, it's not just physical books that are being loaned through the library. This could also inform the library to make smarter business decisions on what type of book formats are popular amongst its users, and what to like put funds towards as they're purchasing new books for the library. So I would also want to extend the penalties to the different types of penalties, not just late fees, because as you borrow books from the library, like anything could happen. So these penalties could be for lost books as well as damaged books, and this could help the library system see what type of like how many books are being lost or damaged, and it could help them be informed if they need to enforce more, either more like communication through their branch of how to handle books or what's expected of the users when they return books. And also is to add an address and home library column to the user table, and also a check constraint by zip code to assign users like a home library branch. This could also see insights to see where where like people who use the library most are, and could also potentially see where the library may need to open up more branches, or even see what where it's more active as well in the community to drive community events as well as promotions. So thank you for your attention, and we are open to any questions that you may have.
Questions. So as I was mentioned about the scalability in the future. So can you explain one point about the like how will you scalability on this database?
Yeah, so scalability from this database not only incorporates the scalability of adding more users, more books, and more branches, but also could be scaled like grander, not just to like a local library system, but even could be used like a nationwide, so like like an American public library. Just that way, like no matter how big how many users you have, how many staff, how many books, this system could be used just depending on what the business needs are.
Okay, thank you.
Okay, I have another question. Take it easy. I want to know, what do you think was the most challenging part of your project, and how did you solve it?
So I would say most challenging part of the project, honestly, probably was just figuring out like going from the ERD to the actual tables, because we know how like a library system works, but just putting it on paper as an ERD and thinking about it from a database management engineering mindset rather than just a public user mindset was probably more difficult, because there are certain things about a library that like you wouldn't think about as a normal user, just versus that you have to think about as a data engineer. So breaking entities down, like like say a user, for example, it's like, what do I need as an engineer to see this from that point of view? So thinking about things like the ID, how would that incorporate to the bigger picture, or even like the afterthought of like a different branch, things like that probably would have been the most difficult, as well as just using software in general. Tableau, learning like just being able to use Tableau versus like Microsoft Excel for the graphs, as well as the coding and creating some of the checkpoints as well, since those are relatively new and new like skills that professor has taught in class, and seeing those work out like in real life.
Oh, great. Thank you.
I have a question.
Yeah.
Could you please briefly explain the relationship between loans and penalties and staff? So I want to know which relationship was the most complex to design.
Okay, I'll take this. So when a user borrows a book, a loan record is created. If the book is returned late, a penalty linked to the loan is created. Meanwhile, a staff member is associated with the loan because they facilitated the borrowing or return process, ensuring everything stays organized. And coming to the design, which was the relationship was the most complex one, was designing the penalties and loans. Loan relationship was the most complex. We had to make sure the penalties are accurately tied to overdue loans, and we also included calculated columns to track overdue days and dynamic days dynamically. So yeah.
Yeah, and I'd also like to point out on the loan table too, if you notice like on the ERD, the loan to penalty, unlike many other entity relationships in the diagram, this one is a 1-to-1 to 0 or 1 relationship, meaning that one loan is one penalty. That way we can go back and if like you're using this in real like as a scale like in a library, that means like only one loan has one penalty. They can't incur multiple penalties on the same loan. That way like a user won't be like double charged or like charged twice for like the same loan. Any other questions?
Great work and presentation from Team 5. Your future work was very interesting. And also your Q&A session was outstanding. Thank you. Thank you, Team 5, and thank you for the questions. Last but not the least, let's welcome Team 6. Okay, Team 6, you are not audible yet. Okay.
Hello? Can
Yeah.
you see my screen?
Yeah, could you put your slides in the presentation mode?
Like
Yeah,
this.
okay. Excellent.
Thank you. Hello, everyone. I'm Qilian Liao, and we are Team 6. Our project is called Simple Sales System. Over the past few weeks, we've been working together to build a database system that supports the core operations of sales-based business, from designing the structure to implementing the logic and visualizing the data. We try to make it as real-world ready as possible. So here is a quick roadmap of what we'll cover today. First, Min will talk about why we chose this idea and what our system is built to do. Then Zhenting will walk you through our ERD and key design decisions. And then I'll take over to explain the SQL DDL part, the main tables, constraints, and some cool logic we added. I also introduce the reporting views we created in SQL for business insight. Then we'll hand it over to Rena, who will show how we brought some of those views to life using Tableau. Cassandra will wrap things up with some challenges we faced and what we learned from this project. And finally, we'll open the floor for Q&A. We are happy to answer any question you have. All right, let's get it off. I'll pass it over to Zimin to get started with our motivation and project scope.
Thank you, Lily. Hello, everyone. I will explain our team choose to design why our team choose to design a simple sales system. First, the rapid growth of e-commerce has transformed customer behavior and how people shopping. So many of us frequently purchase items from online platforms and are curious about the underlying data management and logic. Sorry, it's the previous slides. Yeah. Support such system in the online shopping. So these projects allowed us to design and implement an industry level sales system database from scratch. We want to gain a deeper understanding of how large volume of product and sales data are managed effectively. So this sales system primary strength is improving product sales, inventory tracking, and transaction processing. And finally, the module structure allows adding features like new payment gateway or logistic integrations without disrupting nowadays workflows. So this makes these systems future-proofs and allowing it to evolve with business requirements. Next, please. And now I will introduce our project purpose. First, the product and category management, allowing clear organization of product details, pricing, stock quantities, and improving navigation and searchabilities. Second, the customer and sales order management, by effectively tracking customer information and sales orders. This system ensures a smooth process from order placement to completion. Third, the inventory and supplier recorder management. The system closely monitors stock levels, automatically processing supplier orders when inventory runs low, and making sure that product availability are smooth operation. And fourth, the payment and refund process. Our platform efficiently managing transaction by securely processing payment and handles refund immediately, reinforcing customer trust and satisfaction. Lastly, order shipping and delivery tracking, providing transparent shipping details, tracking numbers, and estimate delivery dates, improving the customer experience through this reliable logistics. Now I will hand it to Zhenting for his part.
Okay, thank you. I'm Andy from Team 6, and I will be presenting the final ERD overview for our single cell system project. So as you can see on the slide, our ERD includes 12 entities designed to manage sales and inventory and transaction easily. So I will start with the blue color of product management. We have entities like product, category, and supplier. So products belongs to one category and is supplied by one supplier. But a category can have multiple products as well as a supplier provides multiple products. Therefore, as shown by the one-to-many relationships. So moving to the green color of sales management, the sales order entity track customer purchases, and it is linked to the customer entity. So notice the bridge table of the sales order detail, which connects the sales order and product table to handle the many-to-many relationship. And then for the orange color of inventory management, we have the inventory entity, which has a one-to-one relationship with product table to track stock levels. And the supplier order table and its bridge table supplier order details manage the restocking from the suppliers. Finally, the red color of transaction management includes the payment, refund, and shipping entities. All connect to the sales order table with one-to-one relationship to ensure order processing. Okay, next slide, please. Now, I will move on to the key design highlights, where I will focus on one of our core design decisions, how to avoid many-to-many relationships Many-to-many relationships can cause redundancy and complexity in database design. So in order to create a normalized and efficient system, we use the bridge tables. So here are the two examples we use in our database design. So first, consider the relationship between the sales order and products. A sales order can include multiple products, and a product can appear in multiple orders. So this is a many-to-many relationship. To resolve this, we introduced the sales order detail bridge table. And this table links both entities and records details like quantities and unit price for each product in order. So this table will help us maintain accurate data and makes query easier. And in the same way, the supply order detail bridge table handles the many-to-many relationship between supply order and products, storing quantities and unit price for each product in a supplier order. So by using these bridge tables, we have ensured our database follow the third normal form. This will help prevent redundancy and make it easier to manage the large volume of data. Okay, I will stop from here and hand it over to my next teammate.
Thank you, Andy. Hi, everyone. This is me, Chilean again. Let me walk you through the key highlights of our SQL DDL implementation. In our project, we implemented a total of 12 entities in our database, each with a clearly defined primary key and appropriate relationships. The design follows the third normal form and to eliminate redundancy and ensure data integrity. Throughout our DDL, we applied important SQL constraints such as identity for auto-incrementing primary keys, not null to ensure required fields are not left empty, check constraints for business rules, foreign key constraints to maintain referential integrity, and unique constraints for one-to-one relationship. These constraints help us enforce both data correctness and real-world business logic directly at the database level. So, one of our code example is our product table. Here's the structure we use. You can see the code here. In this table, we use identity one-on-one for primary key product ID. Non-null ensures in fields like name, price, and stock quantity are always provided. The check stock quantity is bigger and equals 0 constraints prevents inserting negative inventory values. We also have two foreign keys, category ID and supplier ID, connecting to their respective tables. So this simple example shows how we use SQL to enforce business rules even at the structural level. Next, this implementation section demonstrates how we implemented advanced data integrity rules using SQL functions and constraints to automate calculation and prevent invalid business operations. Let me go through some important details in following pages. In the sales order detail table, we initially defined a regular subtotal column. So later we enhanced this by replacing it with a computed column using a user-defined function in SQL Server. So this function automatically calculates the subtotal by multiplying quantity and unit price. Since it's marked persisted, the result is physically stored in the table, to improve performance. So this approach ensures consistency, avoids manual errors, and shows how database functions can support automation and reliability. Next, important details we want to mention is in addition to computed columns, we also implemented advanced table level constraint using this function. The goal was to enforce a business rule. The total ordered quantity of a product must not exceed the available stock. So we found this very important. So in our table, you can see the check total stock availability function performs a subquery to compare the sum of all ordered quantities with the product stock level. So if any product is oversold, the constraint fails and the transaction will be blocked. So this is a great example of how SQL Server logic can be used to simulate real-world inventory control. So, and then next, now that we've walked through how we built the database structure using SQL DDL and enforced business rules through constraints and functions. So now I want to move on reporting views where we demonstrate how it extracts meaningful insights from the data. So from each view, we prepared 6 views. So for each view, I present the SQL code that defines it on the left side and the visualized chart on the right side. So this allowed me to build clear and readable charts and tables can help illustrate how each view can apply it in real-world reporting scenarios. So I hope to give you a better understanding of our logic and how these views support specific business needs. So so in other words, I want to highlight the SQL behind it. So why each view was created and how it could be useful in a reporting environment. So after I walk through the reporting views, one of our teammates, Rena, will take over and show how some of the same or other views are implemented and visualized in Tableau. So you can get a better sense of them. So let's see our 6 SQL reporting views. View 1, this view displays each product along with its current stock level. So it joins the product and inventory tables to help warehouse team or purchasing managers monitor product availability in real time. It's a it's very important to have it. Then we can control the inventory at time by time. Next, view 2. This view shows how many orders each customer has placed. So we can see the orders from customer. So this will help us analyze customer activity and track engagement over time. This can support CRM strategies or loyalty programs based on customer purchase frequency. But it is hard to show the habits only shows the frequency of each customer. View 3, this view identifies the best selling product based on total quantity sold. It's pretty helpful for marketing team, allowing them to promote high demand items or analyze seasonal trends to get better preparation for inventory. View 4. This view lists all sales orders that have not been shipped yet. What Andy mentioned was we have like payment, shipment, parts. So this is the implementation we can use. So since and it's different. It's not like a chart or like other visualized chart. It shows like a forms. Shows like a form. Since this view lists individual unshipped orders, it's better shown as a table rather than chart because we need the customer or we need the orders details. So it's essential for logistics team to quickly identify pending deliveries and avoid delays. This ensures smooth order fulfillment and better customer satisfaction. View 5. This view summarizes payment behavior by aggregating the number of payments and total collected amount per method. It helps the finance team understand which payment channels are most frequently used and most profitable. And then view 6, this view flags product whose stock level is below a certain threshold. In our case, less than 50, we set the default quantity is less than 50. So it joins product, inventory, and category tables to provide a full view for the inventory management team. This view supports reorder decisions and helps prevent stock outs. And that wraps up the reporting views and intentions I prepared using SQL and other visualization tools. Now I'll hand it over to Rena, who will walk you through how some of these views were implemented in Tableau for interactive reporting.
Thank you. Thank you. Hello, everyone. About the Tableau reporting highlights. On TwoTech, we have two Tableau visualizations, so we create to provide business insight. One is product inventory level, and the other one is payment method summary. So for the first one, we create a SQL view called product inventory view, which joins the product and inventory tables to show us each product along with its real-time stock level. So the purpose of this view is to track product availability and to identify low stock items that may need to be reordered. So one of them is quickly identify low stock products. The use of the red and green coloring makes it visually obvious which items need restocking. And the other one is support fast restocking decision, which is managers can instantly prioritize which products to reorder without reading tables. Then we use the data Tableau to build a product inventory bar chart. So we drag the product name to the column shelf, then we use stock level in the row shelf to visualize total stock. To make the chart more meaningful, we create the calculated field called stock color. And also we create another calculate field named stock label. This label helps visually tag low stock items directly on the chart. And then we drag both stock level and stock label to the label shelf for clarity. To improve the chart further, we added a reference line at the 100 unit mark. This line acts as a reorder threshold. It's shown as a dashed red line to make it more visible, and some products are well stocked. However, some items which are at zero stock, but we need urgent attention. This view provides a glance summary of which products are healthy in stock and which ones need action. Next page, please. All right. So the second view is the payment summary by method. For this, we create another SQL view called payment summary by method to analyze how customers are paying and how much revenue each payment method generates. The goal of this view is to support the finance team by showing which payment methods are like visualize payment method usage at a glance, and the other one is help finance team analyze customer payment preferences. So we brought this data into Tableau and create pie chart with the following setup, like we change the mark type to pie and we drag payment count to angle so that larger slides represent more frequent payment method. We also include payment method and count as labels directly on the chart. Then we change the layout to entire view, so the pie chart appears centered and clear. And also key insight from the pie chart is the most used method is a credit card, making up 5 out of 10 payments. PayPal also is popular, used 3 times, and bank transfers were only used twice, which is showing is less preferred by customers. This insight can be valuable for making decisions about like which payment methods to prioritize, advertise, or even streamline. It may also influence future marketing strategies like offering promotions on popular payment channels. So to summarize, the product interval bar chart helps identify stock level, restock needs, and potential out-of-stock items quickly. And also the payment method pie chart gives a financial overview of customer preferences, like helping the strategic decision-making for payment options. Thank you. You can go to the next slide. I pass it to my teammate.
Okay, hi everyone. So I'll quickly go over some key challenges we faced and what we took away from this project. One challenge was modeling real-world relationship correctly. For instance, we initially thought some entities like orders and shipping might be one-to-many, but we later realized they should be one-to-one, so we refined it. Another challenge was enforcing logic directly in SQL. We didn't want to rely only on application code, so we use constraints and customer check functions. For example, making sure the order quantity doesn't exceed the available stock. And we also added computed columns like subtotal, which help keep the data consistent. So throughout this, we learned a lot how to design in the third normal form, use bridge tables to avoid many-to-many relationships, and create SQL views for reporting. And personally, I gained a better understanding of team-based development using Git, reviewing each other's work, and fixing issues together really make it feel like a real project. And next slide, please. So yeah, overall, this project helped us connect theory with real-world database design. We designed a full system from scratch that can actually support a small e-commerce business from inventory to payments to reporting. So thank you all for listening. It was a bit intense at times, but honestly, a lot of fun too. So we're Team 6 and we'll be happy to take your questions now.
Hi, Team 6. Thank you for your presentation. I really enjoyed the really in-depth visuals as well as analysis of your project. One question that I have was, I see that you included like payment methods as one of the visuals and highlights of the project. I was wondering in a future instance of this project, would you consider adding in more financial information and tables and visuals to help support the database? And if so, like what would be like the first entity you would want to create there?
Okay, so let me quickly repeat your question to show that I really understand it. Do you mean the current database support multiple payment method, and how would us extend to handle more complex financial features in the future? Is that what you meant?
Yeah, like similar, like from the payment and refund tables I'm seeing there, like how would you, I guess, extend that to handle like like the product pricing or like pricing per like say user, similar to some stuff that we've done in class?
Oh yeah, so if we wanted to support more like complex features in the future, maybe like split payments, gift cards, maybe something like that, we will extend the schema by creating a separate like payment method table and linking to a foreign key. And we will also add something like transaction history table to track payment status changes over time. So that's what we might do if like we can extend it.
Awesome, thank you so much.
Thank you.
I have a question. So how did you decide which relationships should be one-to-one versus one-to-many in your final ERD? And were there any relationships that changed during your design process?
Okay, thank you for your question. So in our initial ERD, we had a few relationships that weren't clearly defined, especially between entities like sales order and payment or shipping. So we thought more about real-world business logic. So we realized that each sales order should have exactly one payment and one shipping record. So we changed those relationships from one-to-one to one-to-many to one-to-one. This helps us avoid duplication and enforce better data integrity. And we also made sure each product maps to a single inventory record, like not multiple, which was another shift to a one-to-one relationship. So that's pretty much it. In short, we refined the relationships based on what we would make the most sense in the real e-commerce setting.
Oh, thank you.
Thank you.
I have a question. What was the most challenging thing about this project, and how did you overcome it?
Well, to be honest, each part, to me personally, each part is challenging. Like, but if I'd think about the most challenge part, I'd say version control and and some relationships like between orders, payments, and shipping were unclear at first. Another one was enforcing data integrity using SQL. Like we used constraints and customer functions to handle things like valid order status and make sure stock levels didn't drop below 0. And that's pretty much it. Thank you.
Thanks.
Okay, thank you, everyone. Do you have any other questions?
Great work and presentation from Team 6. Team 6, I really like your views and how the views were used for reporting and data analysis. Also, your conclusion was very interesting. Thank you for the great work from Team 6 and thank you for the questions.
Thank you, Simon.
Your presentations were outstanding, and I was impressed with your accomplishments in data management and database design. Congratulations to everyone. This is the end of our project presentation.